Welcome! In this new presentation we are going to see some different methods that can be applied in order to perform a good thermogravimetric analysis. This is our contents outline. First of all, we will see some previous consideration regarding the parameters that you can play with in order to perform and design a good method, and then we will go through the different methods that you can apply, such as the isothermal, isostep, as well as dynamic. Regarding the previous knowledge that you have to have before understanding this presentation, you have to know some fundamentals about TGA analysis as well as some experimentation skills. Let's start then answering the question, which are the parameters that we have to play with in order to design a good method? These are three parameters. First of all, temperature, then time, and then which is the gas that we are going to apply in our analysis. By the combination of the temperature and time, we can define some different methods, such as the isothermal and dynamic methods. A combination of both, isothermal and dynamic, will result in the method which is known as isostep. Regarding the gas that we use for our analysis, we have to define, first of all, which is the flux. That means the amount of gas per time unit that you are applying. And most important question, do we want the gas to react with our sample? If we don't want that, so we only want to analyze the thermal stability of our sample, we will have to apply an inert gas, such as argon or nitrogen. If we want a reaction between our sample and the environment, we will have to apply some oxygen or air in order to have a reactive atmosphere. Let's see then, according to the different combinations of temperature and time, the different methods that we can apply. When we define an isothermal method, we define a constant temperature along an established time. If we make some different steps, this is the isostep method, in which some isothermal segments at different temperatures are defined. We can define some different dynamic steps between these isothermal segments. Finally, if we define a dynamic method, the initial and ending temperatures are defined, or told in other ways, we can define a constant heating rate. Which is most important is that this method is the one that is used more broadly. Remember what we have seen here. We have defined which are the parameters to define a good method, which are the relationship between the time and the temperature and the gas of analysis. Then we have seen the three main thermogravimetric methods, isothermal, isostep, and dynamic. And finally, and keep that in mind, is that the dynamic methods are the mostly used. Now it's your time to decide which is your best method to your experiments.